We're looking at polynomials and the rules of exponents. Very important concept in mathematics. Polynomials, of course, as you study them and some of the applications, there's polynomial functions, but you can also see how they're used in building roller coasters and just what some of the polynomial graphs would look like. If you were to graph certain polynomials, different details, you begin to picture, things like roller coasters. Now, there's more that goes into that, but I just think it's interesting, just the what you can learn about polynomials and roller coasters if you were to do the research. But in this video, I just want to talk about the rules of exponents and how they tie to polynomials. So basically, when somebody says 5 squared times 5 cubed, that is the same thing as that, okay? 5 squared times 5 cubed is the same as just adding the exponents and you get 5 to the 5th power. Well, why is that? Because whenever you have the same base, okay, you have the same base and you have exponents sharing the same base, you can add those exponents. If you have the same base and they're dividing, you subtract those exponents, okay, and x cannot equal 0, as you note here. Now the same thing, x to the 0 power is 1. And if you have two things in a parentheses with a power outside, again, the exponents will multiply out. Please, this is different from when these two things are adding. This is only when they're multiplying. And the same thing works with when they're dividing in a parentheses. That power comes into each of those terms. These rules are listed in our Tools for Math packet. They're available on the internet. You can just search for the rules of exponents or exponent properties. And it's important that you know how to use them because they will help you as you go through algebra. And so here's one more example. 2 to the 3rd power times 2 to the 4th power will be 2 to the 7th power. 2 to the 5th power times 2 to the negative 8th power will be the same thing as 2 to the negative 3rd power. That's because 5 plus negative 8 is 2 to the negative 3. Now that becomes 1 over 2 to the 3rd, which is another rule of exponents, negative exponent property. You're allowed to bring the number down and change it to a positive, okay? So that's how you would deal with that. Now again, the examples are available as well as the properties themselves. But let me just say one quick thing about how polynomials would work if you were adding them. If you have 2x squared plus 5, and that's adding to 4x cubed plus 2x squared plus 6, you would only add the terms that are like terms. Like terms are terms that have the same variable in the same power. So they need to have two things in order to be like terms. The same variable in the same power. Now notice that 5 is the same thing as 5x to the 0. And 6 is 6x to the 0. So those two can add also. That will give us 11, of course. And then 2 plus 2, we have 4x squared plus 11. That's what's going to happen. But the 4x cubed will just come to the front, okay? And that just stays that way. Again, notice that the like terms add, everything else just stays the same, but we're going to order it from the greatest power to the least, okay? And so 3, 2, there's no first power. You can think of it as 0x to the first power. That's why it's gone. And then the 11. So that's how polynomials work in that context of adding them and subtracting them. But let's take a second now to quickly look at multiplying them, okay? If you're adding or subtracting, you would do the same. But let's look at how we would multiply polynomials, okay? One method people talk about is FOIL, first, outer, inner, last. But you don't always have to go that route. If you had 2x plus 5, and that's multiplying 4x plus 7, then you can just say 2x times 4x, which would be 8x squared. And then 2x times 7, 14x. 5 times 4x is 20x. And 5 times 7 is 35. Or you can write it this way using like Punnett squares from biology. If you have 2x there and the 5, the positive 5, and you have 4x and you have the 7, you just go ahead and, fill in the boxes. This box needs those two. So that's 8x squared. Those two, 20x. Those two, 14x. And those two, 35. So then you add the like terms, 20x and 14x. So you have 8x squared plus 34x plus 35. So now we've multiplied polynomials, okay? Using that method, we just put the 2 on top and so on. Now if there's 3 terms, you do the same thing, okay? Everybody needs to essentially shake hands is what's happening. But if you're dividing polynomials, if someone were to ask you what is 8x squared plus 34x plus 35 divided by, let's say, 2x. Well, then you would take each of these individually and divide them by 2x. Okay? You would divide the first term by 2x, the second term by 2x, and the third term by 2x. That's one way you would deal with it. But then, of course, there's the long division details that I explained in our book in 5.7, polynomial division. So, polynomials are very important. There's rules of exponents. There's polynomials for, there's rules for multiplying them, adding and subtracting. Just remember your like terms. So if you want to excel in polynomials, learn your rules of exponents. Learn your exponent properties. Know how to work with integers. Know your arithmetic properly. And you will succeed as you try to do that. So take care and have a wonderful day.